It's basically a fact that those lines are now having a continuity of degree 2. But degree 3 is when you have a continuity with the position, with the radius of curvature, and with tangency. So even the tangents are going to be same. You might have noticed sometimes that the designs that come out of, let's say, Zaha Hadid architects are curvy, but the curve is something different. You cannot just imitate the same curve in your design, even if you draft it. Even if you like take a section of it and you put it on your AutoCAD or whatever software you're using and you draft it, you can't really get the curve. The reason is because most of the curves, most of the continuity of the surfaces that, let's say, someone like Zaha, the company uses, are with a degree of 3, at least 3. Higher, like the next level, the next degree is 4, and degree 4 has the position, the curvature, the tangency, and also something called as acceleration. This degree 4 is mostly used by automobile designers. So when they are designing the surface of your whatever Honda or a Mercedes, they have to take care of aerodynamics as well. And the curves, the continuity that they use is at a more higher degree, which is they also factor in the acceleration, which you can obviously go like you can bring that as well in Rhino, because Rhino was basically made for industrial designers or designers who are dealing with surfaces a lot. So that's why you have this function, but you can use it in your surfaces if you want. But eventually, if you're going to construct it with bricks, your continuity is just a series of chords basically in plan. Does that somewhat answer your question, Sachin? Okay. Let's go ahead. So this is basically the summary of continuity, geometric continuity, and we will, keep bumping into it from time to time when we see continuity between surfaces, which is slightly more interesting than curves, but the continuity between curves is more evident, and you can understand it more easily over here. So moving on, we have these points and curves that we have made now, and we were exclusively working on the perspective screen. Let's double click on it and let's go back in our world and see what kind of mess we have made in all the views. You will see that since you're working on just one view, the default view has made it impossible to see all the objects in all of them. Like the default zoom is only restricted to some point, so you can't see everything. To zoom at the extents for all these views, you can type the command ZEA, which means zoom extents all. So once you type it, everything gets zoomed at its maximum extents in all the views, and you can see it. This command is very helpful when you are just modeling on the fly, designing on the fly, and then you realize, I need to fix that part, and then you go back to something. So zoom extents all is going to help you similarly as it probably was helping you in AutoCAD. So now that we have made these curves and now we can see how they look, let's slightly graduate a little bit to surfaces and see how these curves that we have can be directly exported, directly morphed into surfaces. I'm going to double click the perspective view, and with the curves that we have, I'm going to expose you to a command which directly makes lines into cylindrical surfaces like a pipe, which is the name of the command. So this series of polylines is going to be converted into a pipe. How do we do that? I'm just going to type pipe, and it says select rail. Now, what do you mean by rail? A rail, the concept of rail here is similar to, I would say, as an example, the concept is similar to a roller coaster. Okay, so you have a rail and you have a car. So you have the rail goes all around, blah, 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 and the car sits on it and the car just follows it the way it goes. So it's asking you, which is the rail, the guiding polyline. So in my case, let's say I'm going to say, okay, this guy. The moment I click it, it asks me what's the start radius. So the start radius is something that is displayed here because the cross section of this thing is going to be a circle. So it says, what is the radius that you want? Before typing anything, or let's just type. So I'm just going to go ahead and say, let's say the radius is 1, whatever you say, 1. Okay. So it says, okay, that's the radius. I hit space or enter because I'm done. Then it says, what's the end radius? Because the pipe can probably have a uniform kind of geometry. A non-uniform geometry. So you might want a different radius over there. So I'm going to say, okay, I can put something else. So I'm going to say 2. So as you see, the start radius is 1, the end radius is 2, which also somehow means that my rail started from this direction and ends at this direction, which means my polyline really does have a direction. Because as you might remember, I was selecting the points from left to right, and which means the start radius looks like this, end radius looks like this. Okay. And now that I'm done, I say space or enter. And it now asks me, do you want any more radii? Which means, do you want any more deformations in the pipe? I'm going to say no, not yet. So I'm just going to say enter. And I have this mess in front of me. Go ahead and make a pipe out of your polyline, and let's see how it looks. It's just going to take you probably 2-3 minutes to finish this. So I'm just going to wait for that much time. The steps are simple. You just say, you just type pipe and you select the rail and you put in the radii. Say, okay, 1 and whatever, 2 or whatever you want. And then go ahead. Oops. Okay. Can you see it? I'm assuming that all of you have the pipe. Okay. Okay. So now that we have this geometry and it's not just points and lines, you would have noticed that it is displayed in a very weird form. The form is wireframe. So it is displayed in just the basic building blocks of the surface, which in this case, they are just the circles, the end circles of the cylinder, and the lines that join the quadrants. So to take care of that part, I'm just going to drop down the arrow next to the perspective, the thing that we were talking about in the beginning, that we are going to select something that shows the geometry. So in wireframe, it just shows in a wireframe. The shaded view, shows the shaded view like this. In my case, it shows some fancy shadows. In your case, it might not. Don't worry about it. The rendered view, I would not click it now because then it might make things slightly slow. The ghosted view, where you see everything and the hidden surfaces and lines behind in a slightly ghosted kind of format. And then there are other several views like the X-ray and blah blah blah. Mostly in my workflow, in my Rhino workflow, I mostly use the ghosted view because it gives me an idea of what's behind, and it shows me the surfaces that are made, and it shows me the surfaces that are hollow. Okay, so this is something that I use mostly, but as in terms of processor speed or the kind of memory usage, the best one obviously to use is the wireframe because it's going to take the least amount of memory. So if you have a lot of geometry around, and if you are finding it difficult on your computer to move around, you can use the wireframe. Well, first option obviously is to get a new computer that can take care of your geometry. But the second one, the slightly cheaper way to get around it is, okay, just go to the wireframe and see it. The second most lightest is slightly debatable because it can be somewhere between either the shaded or the ghosted, depending on your geometry. So now that we have seen these views, let's make sure that all of us are in the ghosted view, let's say. Okay, so all of us are in ghosted, and click the display ribbon, the one that I am highlighting over here, the display ribbon that looks like a monitor. Click on it, and now it shows various different things that you want to be visible or not. So shadows, if you want them, you will click and you'll see shadows. I would suggest not to have them at this stage because we are not actually visualizing anything. Surface iso curves. So these are the building blocks that we saw in the wireframes. Surface edges, which I have displayed on because I want to see them all the time, but you can just neglect them. Tangent edges. Tangent seams. Seams is something that we're going to discuss more in detail when we see more advanced surface commands such as loft. So these are seams. Then mesh wires, it's immaterial because we don't have any meshes. Then curves. So the curves that we have made over here are being displayed or not, depending on if you want them. Points, yes or no. Many times I get these kind of doubts from students that, hey Angad, I've made this geometry but I can't see it. Well, you can't see it because you have to go in your display ribbon, make sure that you have clicked it on. If you're making curves and you don't want to see curves, then you're not going to see curves. So rookie mistake, make sure you always check what you want to be displayed and if it's on or not in that specific view. So this is specific to the ghosted view. I can go to the shaded view and make the same changes, like for example, knock off the shadow, and now I see everything like probably you would be seeing now. With the surface edges, yes, more similar to how it looks at your end, and so on and so forth. Yeah, I think we are slightly running behind schedule. So what I'm going to do is I'm just going to delete these guys and show you something more about pipe that we probably couldn't see in this case. So I'm going to just pipe my other geometry here. I'm just going to say pipe, and it says select rail. Yes, select rail. Now, the moment I select the rail for pipe, My command prompt has other options. As you might see, it says start radius too, and it's asking me, do you want to keep it the same start radius or do you want to put something else? But apart from that, it also has some different options inside the parenthesis. Like for example, it says instead of radius, do you want to just put in the diameter? Because some people are more comfortable with diameters when it comes to pipes or circles. Do you want it to be thick, which means do you want the surface to have some thickness? Like for example, now it has unit thickness. So like there is no thickness to it as such. It's just unit thickness, whatever. It's 1 millimeter now at this stage, but it's not really a thickness. It just exists over there. But do you really want it to be thick like a material or not? Do you want it to be capped, which means right now we had those as hollow, like in your case they would have been surely hollow pipes, but do you want to cap them? So I'm going to say okay, probably cap them as round, so they're going to have little spheres at their ends. And do you want to blend the shape? So local blending or global blending, we will see this more in detail with other more advanced surface commands. Also the fit rail, we're going to see it more comfortably and conveniently explained in other surface commands. But for now, make sure that you have either flat cap or round cap. And also I think it's a good time to understand that there are more options in the brackets which can give you possibly more different kinds of things that you can do with your geometries. So I'm going to switch back to radius and I'm going to say 1 for the start, and I'm going to say let's say 2 for the end, but at the middle somewhere over here, which I cannot find right now, the midpoint. So I'm going to go ahead and make sure that my midpoint is snapped on, and now yeah, I can find it. Okay, so at the midpoint I'm going to say here, let's say the radius is something like 4, and I'm going to say okay, go ahead. So you see, it makes this turd looking shape. I'm going to see how it looks in the shaded view where I have the shadows off, but it doesn't matter. I'm going to look at it in a fancy view, which is a recent addition to Rhino. It's called the Arctic view. So I go in the Arctic view and see it. It has some very nice looking shadows. It's obviously not rendered as such. This is just OpenGL display. So, but you can see it here in this form. I'm going to go to the display and I'm going to say, I don't want to see curves. So it says no curves. Make sure that the shadows are on. Right now I have put a color over here, which is why it shows the blue. If I click on the color, it gives me different colors to select, and I can say, okay, let's put it dark gray or something. So yeah, it's less disruptive to the eye. And I have this. So let's say I made this turd looking object, and now I want to export it as a JPEG or a PNG or whatever, and I want to put it on my panel, where probably, hopefully, I'm not going to use Photoshop, but something like InDesign or Illustrator to make my panel, and I want it to be there. So how do I do that? The simplest way to do it is by exporting this, and by typing dash view capture to file. Okay, the command is displayed on my screen and you can see it more easily. If you want, I'm going to type it in the broadcast message as well. Dash view capture to file. Make sure that you don't forget the dash or hyphen or whatever you call it. Okay, so you type hyphen view capture to file and you press space. If you don't type the hyphen, you won't see all the options that are being displayed over here. So the moment you say hyphen view capture to file, it is asking you a lot of different things now. Like for example, how big should this export be? Should this capture be? Is it something in pixels or whatever? So I'm going to say yes, it's in pixels. I'm going to say it's something like 3000 by 1500 pixels. And there are lots of other options which you can go ahead and select, like if you want the world access on or not, blah 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 blah. The transparent background is not that helpful, but yeah, I would suggest you to keep it as no for now. Number of passes, just keep the default, and then you say browse. Browse is to place wherever you want. So I'm just going to place it in the desktop, and I'm just going to put today's date. Sorry, and then I'm just going to say third and desktop, and I say save. So now it is on my desktop, and I'm going to go now. Yeah, it might take some time depending on the number of pixels that you have asked to capture. So this is something like taking a snapshot. Okay, it's like on your Mac, you might just do a Command Shift 4, and that's what goes out. Hello. Okay, I think I have. Yeah. So it has been exported. File saved as whatever, blah, 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 blah. I'll go back to the ghosted view. So what have we seen today? We have seen how to make points, and then how to make lines based on those points, how to convert them into curves, and how to make a surface out of those curves in a very, very easy way, and how to have your work exported in just a JPEG format or whatever, PNG format or whatever. So this is the final output, the final turd looking thing that you have. Any questions until this point? Sorry. How did you change the background color? In the Arctic view. Okay. To change the background color in the Arctic view, like let's say we are here in Arctic, make sure that you are in the display ribbon, and the background you say solid color. Okay. The moment you say solid color, it will give you those options. It shows color and then the thing, and then you click on it and you can choose any damn color that you want, whatever. If you have zoomed out too far and if it's too heavy to go in or whatever, select the object and you can type ZS, which means zoom selected, and it just zooms in to the object that you have. It also helps you orbit in a more smoother fashion. Okay, Tejas, did you get it? Okay, okay. So we have about 15 minutes now. Let's get on to the final challenge that you guys have to do, because if we run out of time, I don't want to miss out on that part. If we have some time left, we will make a canopy of sorts to see, to sort of use the tools that we have learned today. So I will just quickly get you guys onto the challenge that you have to do at the end of this session, the end of the webinar. Yeah, there we are. Okay, so are you guys ready? I think you guys are aware of it. But before that, any doubts until now? Any doubts apart from uh, the things that we have not seen yet, probably? But any doubts until now? If you have any doubts, you have like the next minute or something to type. Well, I can't see anyone typing, so I'm just assuming that you guys don't have any doubts. If you have doubts, you can just put them here. Anyways, so I'll just go ahead and explain the challenge to you. Okay, so the challenge is very straightforward, as you guys might have already seen it on the website, on the challenge section. It's very I wouldn't say simple, but yeah, it's very straightforward to do, and it's quite fun to do as well. Well, the major message that I want to convey with this challenge is what happens in using these 3D modeling softwares is you you actually use them to convert your preconceived ideas that you have about design, but you don't actually use the software to design by itself. By that I mean that let's say I want to design, I want to model my phone. Okay, to model my phone, the very normal thing that I'm going to do is look at my phone, measure it probably, and then start modeling it. But that's modeling a phone. If I ask you to design a phone, how would you go ahead? You would probably take a pencil and paper and start sketching, and you might see different iterations by sketching, no matter what your expertise is in sketching or not. You might even color it, render it to get into the mood and try to enhance the details.